Hi class, we're into the final stretch of the semester. We're going to start looking at work and leisure. Work includes both household work and market work, and leisure it counts as recreation. This first section I hope to set things up for you between it's 128 or 129 to 137. I'm going to go a little bit different than we went in class, because I saw a lot of faces that looked at me rather strange once we started to get into comparative statics. So let's start with constraints. We are limited, we are limited by all the time that we can spend T. And each hour of time we have the possibility of spending it in the labor market and earning W, or the wage rate per hour of time. And V is non-wage income. So you look at your wage rate, multiply it by a total amount of time, add non-wage income, and that gives you all your resources that you can spend. The value of all your time plus the value of the non-wage income. Now if we say that time is bounded at 168 hours a week, we see that the total amount that we could spend would be our wage rate times 168 plus non-wage income. Now, what do we want to spend all that on? We want to spend it on two types of goods. Consumption goods, which we can purchase directly in the marketplace, and they have a price, the price of consumption. Or we can spend them on G goods, which are produced in the household, and they're produced as a function of hours spent in the household and goods that we can purchase in the marketplace. They're kind of like C goods, only we combine them with time to produce G goods. So we have utility being obtained from C goods plus G goods and leisure. So utility, we can get it from consumption goods, which we purchase directly in the market for a price. Goods we produce in the home using our household time and purchased inputs, like, I don't know, flour and sugar are the purchased inputs, and time to make a cake, versus the cake we might purchase directly in the bakery, which would be a C good, and leisure. These are the three things that give us utility. Two of these are types of goods which we can consume, and one of this is a time use. So here what we're going to do is we're going to face this constraint, and we're going to try to identify where we maximize utility in obtaining utility from consumption goods, household produced goods, and leisure. That's a little bit different than we've explained so far. It's a little bit different than the book explains as well. Now, just as we have done all along, we're going to draw a graphical analysis of this. Why this extra vertical bar? Because we are bounded by T, a constant T bar, which we can give anything, a day, a month, a year, but we usually say 168 hours in a week. We cannot gain any more time. This other vertical axis is going to eventually measure C plus G goods. And we are saying C plus G goods are perfect substitutes. I don't care whether I purchase that cake in the bakery or whether I combine my time with a bunch of raw ingredients which I have purchased in the marketplace in order to bake that cake. So on our vertical axis we have goods bounded by time, and on the horizontal axis we're going to look at time. And the three time uses we're going to look at are household time, market work time, and leisure time. Now before I get any more complicated on this graph, this is going to define again goods on our vertical axis and time on our horizontal axis. Remember that I get utility, and utility is depicted by these indifference curves here, of which there are an infinite number. They're shaped like this, and I would like to be on a higher one given my constraints. So in class, and a lot of you missed this, we said, well, if I live in a castaway economy, that means I cannot buy anything in the marketplace. So C goods, nope, I can't buy C goods, there's no store. G goods, well, I can produce G goods with my time and anything I find on the island, but these X goods are found goods and they aren't purchased goods. And I can say that I can produce things. Oh, I can produce fire. That's one of the first things I need. Oh, we should consider survivor. So my first hour, I'm gaining production in fire, and it's really productive. And then I'm gathering food, and I'm getting more of these G goods. And I'm cooking the food by the fire, and I'm getting more of these G goods. And I'm bathing in the ocean, I'm getting more of these G goods. And uh-oh, I'm getting tired, so I'm spending more time doing all this stuff, but I'm not getting very far, but I'm still getting a lot. And then at a time, you can actually decrease the more time you spend in household production. So this point of downturn where you're actually getting more time, we're not going to really worry about, but just note we're increasing our household production, our G goods, at a decreasing rate. What does that mean? The slope is declining as I move along this curve. So what if I looked at a utility function and I said, oh, there is, whoops, sorry, that's going to be tangent, folks. There is a utility curve, and I maximize utility here, and I produce G1, household produced goods. Maybe I made a fire, I boiled some water, I caught a fish, I ate it. That would be household production. And at this point, 0A, that's the number of hours I would spend in household production. And given that there's no market to work in, the rest of this, let's call this B, is leisure. So here we have our castaway or our survivor economy where you can't buy anything in the labor market, but you've still chosen to produce things at home, so to speak. So let's continue, and we'll say what happens, same graph, T bar equals 168. Time starts down here on the right hand side. These are G goods. I'm measuring time and goods. And let's say I had this production function, and now all of a sudden I have to, somebody else joins my island. I have a child in my household, or I have company, and you know what? I am more productive in every hour that I spend. So my household production curve has gone up. And I look at where I would have been happy to start with, and I spend OB time in household production and OC time in leisure. That's the baseline. And then my household production goes up, and oh, let's just change colors here. And I say, wow, what's going to happen when household productivity increases? There are a few things that can happen. Notice this slope is steeper, so this curve, given my preferences, are going to hit this where it's steeper, and I know there's so many of these curves, so a few things can happen depending on where your preferences are. So I can, this is going to be bad, folks, but I can be more productive in household productivity. So I spend more time. Now I spend OZ time in the household, and I actually produce more G goods than I did before. So, oops, let's go back and say that's how many G goods I had at first, and I produce more, and I've spent more time in household production. It all depends on the productivity of the curve, the shape of your indifference curve, and where they are tangent. We maximize utility at the point of tangency of the indifference curve and the budget constraint. This is no different than we have been doing all semester. So this is one comparative static. We're already at comparative statics. And what we've just done is we have done the comparative static in this graph of increasing, increasing household productivity, or G sub H. That means every hour I spend in household productivity, I have gotten more. Now, if we had broken our leg, we would have seen that this curve goes down. You're less productive at every hour, and you would accordingly look at an indifference curve. In this case, your household time would decrease, your leisure time would increase, and your G goods would have gone down. Comparative statics, just like we have done all along. So that's if you're in a Robinson Crusoe or Castaway or Survivor economy. We're only looking at household produced goods given a time constraint. Now, moving on, total time is equal to household time plus labor market time plus leisure. That's our total constraint. And if we add market work into the equation, and we have previously looked at income, we know that income is equal to our earnings plus, in our case, V, which is non-wage income. Income is equal to WM plus V. Notice our earnings are our total labor market time multiplied by our wage plus our non-wage income. Now, in our world, remember, we like to expend everything. So the price of consumption times consumption is equal to my income, is equal to my earnings plus V. We knew that PCC, the price of consumption times consumption, is equal to plugging in this into there, WM plus V. And back to here, we know that time is equal to M plus L. And we have plus G, but what if we don't do any household production? So let's move to our total income budget constraint, which is the price of consumption multiplied by consumption, which is total expenditures, equals W. Oh, now we look at things that contribute to leisure, to a utility, which is T minus L. It does equal M, but M doesn't yield utility, plus V. And I finally get my total time budget constraint, which is PC, price of consumption, times consumption, plus the price of leisure times leisure is equal to my total WT plus V, which is where I started on the first graph. So just to finish up this section, let's say now the person does no household production and they only work in the labor market. Now, this person might have some V, non-wage income, remember that. Your non-wage income does not vary by the number of hours. Remember, this is time. Now we only have C as our goods. So regardless of where I am in my utility, I can purchase this amount of C goods without having to work at all. And then I say, oh, WT is this line, W is the slope, T is every hour of time. I have the potential of earning this much per hour spent in the labor market. Until I get to here, I add WT plus V is the maximum amount that I can possibly consume if I worked every hour of my life and I added my V. We know really someone is going to maximize utility somewhere in between here if we simply added an indifference curve in this world where there's no household production. This person will spend OA time in the labor market and AV time in leisure. So we've just looked at a household production model where the person only does household production. Right here, there's no labor market curve. It's only a household production curve. And we've looked at only someone who works in the labor market. And that's a place to stop right now because we're going to pick up the comparative statics of the labor market in a moment.